Hello everyone, and welcome to this Nordic Tech webinar, Accelerate Cellular Product Development, leveraging nRF91 series, nRF Connect, and nRF Cloud services. Today you're going to learn about our two latest devices introduced in the nRF91 series, and the latest updates to our nRF Connect tools and environment for cellular IoT development, as well to the latest services that we are coming with in nRF Cloud services. So this is going to be an exciting presentation, hopefully. Hope you have brought your coffee and tea, and let's just get started. First off, today's speaker, that's me, Martin Lesund. I'm a technical marketing manager for Cellular IoT. I've worked for Nordic for around 6 years. Started off in a technical support group, helping out customers with their customer cases and getting their products to market. And now I work in a product management team, also working kind of on the same thing, just in a different way. So I gather feedback from customer and help that we introduce those features and new stuff into our latest devices and software. And that's one of the cool things that I'm going to show today. Basically what our customers has requested and what we are now providing to hopefully benefit them in their development and product lifetime. So let's just get started here. Just some practicalities in the beginning. We have expected that this webinar will be around 30 minutes. It could be longer, could be shorter. We will also include a questions and answers section at the end. So please type your questions in the questions sidebar, where you can type them anonymously. Please have them relevant to today's topic. If there are some questions that I'm not able to answer at the end of this webinar, or you have some questions after this webinar, you can go to our technical support forum, which is DevZone. And there you can get in contact with our technical support engineers. We also have a chat functionality. This is not anonymous, but it's nice to just say hello to all the people that has joined today. And there will be a recording of this webinar as well. To the slide deck will be provided on this link, webinars.nordicsemi.com. If there's one thing I want you to remember from this webinar, it's basically this picture. Nordic is no longer just a semiconductor company in the regards of providing the hardware. We now are a fully fledged cellular IoT solution company. And what we mean by that is that we provide hardware for the customers. We provide a modem firmware for the customers, which is certified. And we also provide a comprehensive nRF Connect SDK, a software development kit, where our customers can use this SDK to develop their applications on their devices. There in the SDK you have all kinds of samples and drivers and everything that you can make run on your devices. And we also include extensive hardware and software tools for developers to use during their development. As well, we have a world-class support system. We have something called DevZone. There is our support forum with several technical support engineers working day and night to help our customers getting their products out in the market. And we also introduced recently our Dev Academy platform to be a teaching platform for our customers, going through nRF Connect fundamentals, Cellular IoT fundamentals, Bluetooth low energy fundamentals, and there are new lessons incoming. If that doesn't meet your requirements, we also have a Nordic partner program if you need help with antenna design or if you need some other software solutions that you want to include into your program. Just to mention some, you have Memfault for remote debugging, for example, and you also have Avnet, which provides a device management platform for lightweight machine-to-machine protocols. And basically all these benefits from us here is to help customers get their device fast time to market. And this is different from customer to customer and application to application, how long this timeline is, but we try our best to make this process as simple as possible for our customers. And with nRF Cloud, we have newly released some new features that will definitely benefit our customers in their lifetime support for their devices out in the field. For cellular devices running on batteries, some applications are expected to live 12 years out in the field. Then you need to have a secure way to firmware over the air upgrade your devices if you have any bugs that you need to fix, new features that you want to introduce to your applications, etc. As well as device management features we have introduced and new secure services. I'm going to talk more about that later. And with our nRF Cloud solution, you have support for both device to cloud and cloud to cloud solution through REST APIs. So let's start on the left-hand side in the last figure there, our hardware. What is different between our hardware and competitors? We have kind of done a different approach comparing to a traditional cellular solution. We are not just a module. So on the left-hand side, you can see like the traditional way of doing things from several years ago. It's been a way to do it a long time, but we think it's insufficient. And one of the reasons here is that you need to more or less rely on different suppliers for different devices. You need an external host to drive your modem, for example, and if you need to have some secure storage, you most likely need to have a secure element that's separate to the device. And also, if you want power management IC, you need a separate device. So this can make your design more complex, but also the overall power consumption is expected to be higher because it's not kind of optimized in a way to communicate to each other in an efficient way. More about that later on how we do it on our side. So on the 9160 that we released out in the public in 2018, we have put all this into one device, 10 by 16 by 1 millimeter device. It's a system in package, we call it. It includes a power management IC, application processor, and our fully owned modem that we have developed to be optimized for low power and very unique features. And also includes our RF front end in this SIP. So the many benefits here are that you get lower complexity. You only need to have one kind of hardware on your design to integrate almost everything. It's built from the ground up to be low power. Both on the hardware side and on software side, we have modem firmwares that updates and gives new features that improves the power consumption continuously. So you can expect a total lower cost of ownership, more simpler supply chain, and you can see here support and maintained and globally certified. So our device is globally certified. And if you have an issue in the fields or during your development, we can definitely help you out because we own the solution. We can do fixes right away, both on the modem side and on the software side. So that's a big benefit for this kind of way of doing things. And this is just to highlight some devices that are integrated using the 9160. You have different asset trackers, you have smart metering, and many things. So if you go on nordicsemi.com, you can go to this news section, and we publish different devices here that uses 9160 if you want to look more into these devices. So now to introduce the first device that are coming in the 91 series, it's the 9161. And this is based on the same foundation as the 9160. So you have the ARM Cortex M33 application processor, fully dedicated for a user application with your own 1 megabyte of flash, 256K of RAM. You also have ARM Trust Zone for non-secure and secure separation for, let's say, storage or communication there. And you have CryptoCell for deciphering and cryptography functionality. And if you already have a 9160 in your product right now, it's a very minimal firmware migration effort to update to this 9161. And there's also a small thing that you need to do on your hardware design because there's a small change in the footprint. So it's a minimal effort for migration. And we have this modem inside. Now we have support for 3GPP release 14, fully baseline support there, as well as the introduction of the DECT NR Plus stack, which you can run on the modem. We also introduce a new band for Cellular, the band 85. And you can see on the block diagram here the application separation versus the modem. So on the modem side, you can run your Cellular stack or your DECT NR Plus stack. If you don't know what DECT NR Plus is, it's a technology made for massive IoT. It's the first non-cellular 5G technology, so you don't need to use a SIM card, and it's basically a technology for robust, massive mesh applications. We have several webinars going through what DECT NR Plus is, and it's also information on our website, so please look into that if you are interested. But this 9161 is one of the first devices that will have fully support for the DECT NR Plus stack. So you can choose between having Cellular running on the modem or DECT NR Plus stack. It has a small form factor. It is the same form factor as the 9160. It's 10 by 16 by 1 millimeter, and you have a supply range of 3 volts up to 5.5 volts, as well as the temperature range of -40 to 85. The PSM floor current of the whole device is 2.7 microamps, and we have development hardware that's coming out later on down the line. It's the 9161 DK and the Thingy 91X, and we expect this device to be publicly available for everyone in Q1 2024, as well as the development kits. But if you're interested already to test them out and test out all the new features, please contact our sales representatives, and you can get a hold of some samples so you can get started to do some initial developments. Just some information on the Thingy 91X. New additions there is the NRF 7002 Wi-Fi device, which will provide Wi-Fi SSID location features, as well as the NRF 52840 from the old Thingy 91 is now upgraded to the 5340, and we also have 2 new PMICs on the device itself, so it's a very nice prototyping platform. Now over to the 9131 mini SIP. So this is a smaller system in package. It's just 11 by 7 millimeters. So it has a reduction of 50% and 25% height reduction compared to the 9160 and 61. It's fully feature and software compatible with the 9161, So this is a device that's mostly targeted to NR Plus customers or applications. However, this can also be interesting for customers that has high volume cellular products. We expect around 500k pieces per year. And the reason for this is we have taken out the PMIC and some passives and crystals out of design to make it smaller. So it's up to the customer to do the certification of their whole design compared to the 9160, which we have done more of the certification with. So if you're going to use this device, basically it's more effort on the certification process. So it can be more costly. So that's why we see that it's beneficial to do this when you have high volumes. So to make it more simpler for customers, we provide the full reference design and bill of materials to ensure that our users get the best performance on both supported technologies, so Cellular and DECT NR+, and also to limit the certification scope, basically. And this will reduce risk, cost, and schedule versus a traditional Cellular chipset design. So this is kind of in between a chipset and a module, you could say, with regards to the certification race. I would think would be the correct way of thinking about this. We will also have some development hardware around this device. We will provide a 9131 EK for proof of concepts and pilot testing. This will be a smaller sized evaluation kit. And for development on this device, we recommend using the 9161 development kit because it's already feature and software compatible with this device. So the timeline for this device is also Q1 2024. And with the introduction of new hardware, we also have upped our modem firmware for the Cellular side with new features, and the first Cellular modem firmware will be for these devices our modem firmware 2.0. So this device will, this stack will be fully 3GPP release 14 certified or supported, as well as having GNSS. New features here are power saving mode for roaming devices. So you will get power saving mode like sleep still on roaming devices. This has been an issue for a long time, using a SIM card that's roaming on a network and not getting the actual PSM timers from the network. So now we have updated a new feature on our device side that can give you this feature here. Also improved the time to first fix performance with something called offline GPS satellite acquisition, and soft SIM support, of course. And we have this stack globally certified with all the big carriers. That's the plan for this stack here. Unfortunately, this will not be supported on the 9160, but for the 9160 we will of course fully do lifetime support on the 13X branch for every customer that's using that. It will not have new features, but it is in maintenance mode. So all new features from us going forward will be on this Modem Firmware 2, which are just for the 9161 and 31 as for now. And you also have the opportunity to run the DECT NR+ stack. This is a license exempt, highly scalable and decentralized massive mesh technology. And it's using the 1.9 gigahertz global band. And Wirepass is a company that's providing this NR+ firmware and SDK for our customers. And now over to evaluation and our tools there. NRF Connect for evaluation. So we have different tools and ways to help out our customers during the evaluation stage, basically the stage before development, to do power measurement evaluation, for example. And we have a tool called the Online Power Profiler tool. You can see it in the snippet over there, where basically you select your network configurations and it calculates an estimated power consumption of your device. We also have tools to do power measurements and to run modem performance tests and test out cloud services. So basically, this online power profiler is located on DevZone. You go to devzone.nordicsemi.com, which is our support portal, and you can click it there or find it on the top here. And we have an online power profiler for several devices, and for the nRF52 and also Wi-Fi, as well as Cellular. So when you want to evaluate the 91 series, you can start with this, and you can select between LTM, NB-IoT. If you're going to use PSM mode, RC idle mode, let's say EDRX intervals for 40 seconds, and you can see the total average current estimates here. And the nice thing with this online power profiler is that you can select presets of network parameters of networks that we already know the network parameters. So you can select a Cellular network in Norway and you get the correct parameters for that network, so you can kind of evaluate how much power consumption your device would use in one network versus another one. This is based mainly on the different parameters the network provides you, and they don't provide always the same parameters basically. On the desktop side, we have nRF Connect for desktop, which is a launcher tool including all the different helpful desktop tools for our customers. And one of them are this power profiler, which you use to measure power consumption. And you also have a tool called Cellular Monitor. This is something we recently introduced, and this basically takes in the old LT Link Monitor tool and the Trace Collector tool into one tool, plus new features and better usability, I would say. So in this tool, you can analyze modem traces, evaluate communication, as well as do network testing. And to demonstrate this, I want to showcase this. So you go to nRF Connect for desktop and open the Cellular Monitor tool, and you get prompted with this message here. You close this. So as long as your application is using the AT host library and has enabled modem trace, you can directly use this tool. So now I have a Thingy91 connected to my computer and turn it on. I select this device, and now I get some options. You can program the device directly from this application. So here we have some pre-compiled applications for you to test out. We have the cloud sample, the asset tracker version 2. You also have this serial LT modem, which is basically 80 commands directly to the device, basically acting as a standard modem. So your computer works as the host and you issue the 80 commands directly. And we also have this modem shell, which has 80 commands, as well as other features to test PPP or throughput or anything using command line as well. So I have already programmed my device. I'm not going to do that. But now you can start tracing, and you can see on the left hand side, you can see a connection status. And if I do a refresh dashboard, I basically send 80 commands to the device and updates all the parameters in these different sections here. So you can see that I'm connected to Telia Norway, and more information, just hover over the different things, and you can look at the documentation for the 80 commands, or run the command, basically send the command. And from this program you can also open the serial terminal and have that side by side and write in 80 commands directly. Yeah, that's our wrong command. Or you can issue them by hovering over here and running the command here. Or if you refresh dashboard, it will send all the commands to update everything here. The nice thing with this tool is that you do extensive modem tracing of what's happening on the modem side. So you can see you are tracing here on the down left side, and it's continuously increasing. This is a trace file that's being produced, and you can open that in Wireshark. And on the Wireshark side, you can from this application see all the 80 commands that are sent, and the events happening in the modem. So this is a super valuable and beneficial program to use during your debugging and development. And Cellular Monitor itself here is very quick and easy way to evaluate your network. So if you open this and evaluate your network, you can see all the different parameters right away. So that's Cellular Monitor. And for evaluation, we also have technical support with DevZone for any questions that you have. And now, when you're going to develop, we have NRF Connect SDK. This is the unified code base for all Nordic hardware. So you use one code base to rule them all, basically. It's using Zephyr real-time operating system and provides all the protocol stacks, drivers, etc. that you need for your cellular developments. We provide reference applications and samples in the SDK, so you're able to create all your applications directly on the 9161 or 31 or 9160. And we also have a free-to-use IDE, which is NRF Connect for Visual Studio Code. It introduces a lot of nice features built to be optimized towards NRF Connect. So you have device tree integration, which you can see a sample of in the snippet here. So you can select which GPIOs to use for what in a very easy to use way. And it of course includes everything that you expect from a modern IDE. You have all your debugging programming features there. You can do everything visually or through command line. So both are supported, as well as many new features incoming in the future here. And we have Dev Academy for interactive learning. So this is also located on DevZone. You go to Dev Academy here, and you can see NRF Connect for NRF Connect SDK fundamentals. You have Bluetooth Low Energy fundamentals, Cellular IoT fundamentals. So you can go into this course and start basically learning about the theory and exercises to implement reading buttons and controlling LEDs over MQTT, for example, or sending and receiving messages over CoAP. And also how you do debugging with modem tracing, and also at the end here you get a nice lesson around creating a simple asset tracker. So if you're new to Cellular or want to learn more about our Cellular solution or NRF Connect SDK, I highly recommend to start with the Dev Academy. And now let's talk about NRF Cloud. So NRF Cloud basically started off just like a prototype platform for our case, but it's been kind of been an evolution now to being a fully IoT service platform. So we provide different services to benefit applications for our customers. That could be location, that could be lower power protocols, communications, etc., etc. You can use it directly by having the devices directly connected to NRF Cloud. That's called device to cloud, or you can have your own customer cloud and talk to NRF Cloud and get the services through REST APIs. This is a nice way of doing things if you have several other cloud vendors using services from other cloud vendors to combine that in your own cloud. And we have different connectivity transports. We support MQTT, REST, and we are introducing CoAP. CoAP is a UDP-based protocol, which makes it perfect for low power devices. And also it works both for LTM and an NB-IoT, whereas MQTT and typical TCP based protocols can have some struggles running on the NB-IoT technology. So this is a very nice new feature that is coming on NRF Cloud. We also have standalone features for flexible adoption. What we mean by that is that you can pick and choose what services that you need for your application, and you can, whenever you want, disable these services if you don't like them. And that means also a new service that we are introducing is called device management services, which is firmware over the air updates, message storage, and also the possibility of sending device alerts and logs to from your devices there. And also we have our NRF Cloud location services, which now has become 5 services. We have assisted GNSS, which basically means you download the almanac and ephemeris data from the LTE network instead of doing that from the satellites, because that takes a long time, and when the GPS is running all the time, that's drawing a lot of power consumption. So by using assisted GPS or GNSS, you can reduce the time to first fix from minutes down to 5 seconds basically. So you get a much quicker fix, which will reduce power consumption compared to regular GPS. So you can also see here kind of comparing device battery life versus device location accuracy. So you're getting a very great and good location with using this feature. And the next one is predicted GNSS, basically the same as assisted GNSS, but you download a bigger chunk of data so you can stay offline for a longer period of time. And this assisted data is valid for up to 2 weeks until you need to do a new update, so you still get these accurate GPS fixes. So this is very useful when you're going to save more current consumption. And this is kind of the middle man, the golden nugget, I would say. If you introduce a NRF70 series device with one of our cellular devices, you can get SSID Wi-Fi locationing. And here is a very great combination of getting good accuracy as well as low power consumption. You can expect accuracy around 20 to 30 meters, best cases down to 15 meters. This is basically based on how many Wi-Fi access points are around your device. And this also works inside, whereas GPS will not work inside any houses or buildings. Then we have LTM and LTE locationing. First off, multi-cell, basically taking the position of or getting the position of your device based on how many base stations around it. So more base stations mean higher accuracy, so around 500 meters are expected typically on multi-cell, down to a few hundred meters, depends on how many base stations are around your device. However, this is using minimal of power consumption, so if you don't need that high accuracy, this could be a good choice. And at the end, you have single cell, basically just using one single base station. So you can expect a accuracy of 1 kilometer maybe around using this based on your location. But all in all, you can combine, pick and choose whichever service you like and what suits your application. So you can have a multi-cell as well as assisted GPS and Wi-Fi in your device. And a nice thing with NRF Cloud, we have different location vendors underneath us, and we always provide the best location possible for your region, because that's different based on location vendors. Some are good with LTM in North America, for example, but not good with NB-IoT in that section of North America, for example. Whereas in Europe they have some other different things. So we always make sure that the location you get from NRF Cloud is the best one for your device. And now over to the new features on NRF Cloud with regard to security services. And the problem statement here is that all cloud connected devices needs credentials to connect to the cloud securely. And this can be complicated and costly. So that's why we have introduced some features on NRF Cloud to help our customers with this challenge here. And one of them is secure identity. That's the first security services that we are introducing. It provides a secure and unique identity for your device with Nordic root of trust. So you can make sure that the device that you have will be a Nordic device, and you can also use this to check before you give that device access to your cloud or communication, whatever, that this is actually a Nordic device from your fleet. Another service is secure provisioning. Basically means that you can configure the device remotely before it is turned on in the field, and it can get provision with the right credential and custom configurations, and then connect to your cloud account or cloud solution. I'm going to talk more in details what this actually means, because it can be a little bit complicated. Another feature is this IMEI management. Basically, this is beneficial for customers that need to allocate and report their IMEIs with or without their own TAC ranges for provisioning their devices to some specific MNOs. So some MNOs, mobile network operators, would require you to report this. So we give you a nice way to do this easily. First off is this secure identity service, and that's the foundation for the NRF Cloud services and NRF Cloud security services, basically. It's used to verify the legitimacy of the chip, and also to protect the product IP, and also to authenticate devices. And how we do this is that we establish a root of trust during our production. So in our Nordic manufacturing, we do identity generation on the device, which is a unique device ID with a private and public key pair. And also we upload the ID and a public key to NRF Cloud. And thereafter, we deliver the chips to our customers, and during their product manufacturing, they can verify the chip origin and see if this is actually a Nordic device or not through getting a AT command readout from the device. So you're getting an attestation token, and you use that against NRF Cloud, which can verify. And you can do this in a single or bulk way of verifying. And customers, when they go in deploying their device, they can also use this identity to authenticate the device before they give access to their cloud, for example. And this is very beneficial way of securing your device from getting their getting your firmware copied, for example, or someone trying to access your network that has access to your devices. Or something in that kind of matter. So this is a very beneficial feature. Now we have this NRF Cloud Security Secure Provisioning Service, which basically will simplify the provisioning process, configure the device behavior on deployment. It also makes this very flexible and scalable way of doing things. And it also means that you enable a zero-touch provisioning. So what does this mean? Let's say you have a bulk of devices that are shipped to the US, and you have a bulk of devices that are shipped to Sweden, let's say. And you want those devices shipped to US to have some specific power saving mode parameter timers, or want them to connect to a specific cloud or another endpoint. You can set these provisioning rules remotely, and when a device connects, it will download this new updated rules and change the firmware based on that, and also connect to the cloud that you have put in the rules. Whereas you may want to have something different configured to the devices sent to Sweden. Let's say they want to use NB-IoT instead, etc. So you can set different rules for separate devices which you have tagged. And how you do this is basically you bind you claim the device with secure identity service. So you check that this is a Nordic device, and you claim it, and you configure it. And then you do set some tags for the different devices and define the provisioning rules. As I said earlier, you can give it so that it should connect to your remote cloud and give the credentials and some other timers. And when you have securely provisioned the device, you are in here you see when you do the provisioning, you get the keys, and when that's done, you connect to your own application account, application cloud, and you go through this normal application operations. And that's how you get from a blank device to a secure connected device to your own endpoint. And both the secure identity and secure provisioning services is really a breakthrough in making this simpler for customers. So, short nRF91 series, the devices itself is the lowest power on the market for a complete cellular IoT solution. We have low power in our DNA, and we have made sure that our cellular devices follow that rule. We have efficient hardware, firmware, and also protocols, as well as optimized cloud services to help customers get the lowest possible power and longest battery life, which means you can have smaller batteries or save more cost on the battery size. You can verify all this by our Power Profiler Kit 2, which is a little device that's cheap and does power measurements. We also provide security lifecycle. Hopefully you have seen that the 9160 was recently PSA level 2 certified, so we have great security on the hardware side, but also now we have great security on the cloud side for our devices or customers getting their device securely connected from a blank state to a connected cloud. We also have secure boot, authenticated the firmware over the air, secure key and data storage with the help of TrustZone, and also cryptography with CryptoCell. And with the 91 series, you get a reduced cost of ownership. And what we mean by that, you have a single integrated hardware for global deployment. And you only need one hardware for globally deploying a cellular device here, because we don't have any region-specific hardwares. And all the tools and SDKs are available for free for our customers to get their applications and devices out in the market fast. So hopefully all this kind of goes back to this picture here, that we have the full solution for your cellular IoT development process that can basically get your devices faster time to market. Yes, that was all the slides. It didn't last for 30 minutes. I see I used 45 minutes. Hope you have sticked around, because now it's time to do some Q&A. So let's start with the first question. When you say you can choose between DECT NR Plus and Cellular stacks on the 9161, can you switch between them in firmware, or can you only use one or the other? So in a modem, you can only run one stack at a time. So in theory, you can have an external flash that has the DECT NR Plus stack, for example, and then you can switch around when you need to. Let's say you gather information from your other DECT NR Plus nodes to your DECT gateway, and that could switch down to the cellular modem and then send the information through the cellular network. Or you can have two separate devices between each other, one running DECT NR Plus and one continuously using cellular for a continuous stream of data if that's needed in your application. So it's based on what you need for your devices. Here's another question. When will DECT NR Plus be available in NCS? So I'm not going to disclose any future plans for the roadmap on this topic. So right now our DECT NR Plus is provided by Wirepass. So they also provide the SDK there. Next question. Is application processor fully used for application? Also, what is the hardware on the modem? So yes, the application processor is open for the user to program their application, and it's dedicated only for their application. Basically, you have your own flash and RAM there. So the modem is separate inside the SIP, with its own dedicated flash and RAM, basically. And what's the hardware on the modem? So that's a good question. We have our own hardware. We made our own chipset, and we are the only ones that have this modem in the market. And the reason we have created everything ourselves is also one of the reasons we have the lowest power complete cellular solution on the market right now. Will there be NTN support for NR9161 and 31? So NTN, non-terrestrial networks. No, that's not the target for these devices, so that is not supported. Thingy 91X includes all of 7002 Wi-Fi chip, 5340 short-range chip, and 2 PMICs, 1300 and 6001. Yes, that device will include all those chips. And here I see another question. How Nordic see the inter-MCU communication between 91 and 52 or 53 low power UART driver is slow and looks unmaintained. For example, BTHCI over LP UART is unusable with throughput of 2 kilobytes per second. So this is a question around our library, the low power UART. I cannot answer this right now. I need to look into this, but I think this question would be better answered if you go on DevZone and check there. So we can help you out there and get a better intercommunication for you. Next question, how long will the 9160 be available for purchase after the 9161 has been released? That's also a very good question. So we will not stop selling the 9160. It will be fully maintained and you can buy it as long as we have customers buying it. And we also maintain it with new modem firmwares to if there are any bugs or something that needs maintained, then we will release new modem firmwares for our customers. So we will not stop selling the 9160. It will live side by side with the 9161. Next question, is GNSS running along with LTE? So the GNSS can only be used when the LTE radio is not kind of transmitting or receiving. What we mean by that is either the GPS can be used when the device modem is in power saving mode or between EDRX intervals during the RRC idle mode for the modem. So you cannot use it concurrently, but in between each other. So you can get GPS fixes and then talk to the network to send this location, for example. Next question, is it planned to have a Zephyr modem driver for the 91 series, the serial LTM modem application? So again, I cannot disclose future roadmap plans here, but we would be very interested to know what you would need and what benefits you are looking for by doing this. If you go to DevZone and put in a ticket there and write that in, we can look into that. Next question here, has the current consumption of the hardware components like UART, etc. Also been improved on the 9161? And will the data sheets be available for the two models soon? So the hardware component itself are not improved in the regards of current consumption. We have improved on the modem side mostly with new firmware on the modem side. Basically getting a shorter time to first fix on the GPS, using offline satellite acquisition, for example, and also introducing features like roaming PSM. So you can expect a much lower power consumption when you're using the modem. You need to remember that the modem activity is when you use most power consumptions. That is where we have focused our attention on to kind of optimize the power consumption there with new features. And then there's another question, is NRF Cloud only for the 91 devices, or can it be used with, for example, by gateways for the 52 devices? Right now, I think we only have the 91 devices supported, but we may want to support this in the future. So if you put in a DevZone case here as well and provide your needs, we can look into that. And there's another question here about the 9161 will include a soft SIM. Will this support the generic test profile from the TS48 so that no extra SIM card is needed for the mobile radio test with the CMW 500 from Rode and Swatch? So that's a good question. So the 9161 will not include a soft SIM, but you can provision a soft SIM on that device. And right now, as far as I know, it's only on the Mondo that has the possibility of a soft SIM, but there's nothing in the way of any other carriers or MNVNOs or whatever to run a soft SIM. We have the APIs ready available for that. So that means you would need to kind of provision the SIM profile on the device. But with regards to this question about the test profile using the call box, I am not sure to answer that because I don't know. So that is a good question to ask to our technical support forum, so we can look into that. But I would assume that this is the case. Regarding DECT NR+, which channel bandwidth and MCS are supported by the 9161? So for DECT NR+, you would use the 1.9 gigahertz band. And there's another question: when will the 9161 be fully certified? And we will do that around the same time as we release it, is the target. So in Q1 2024, it will be publicly available. So we aim to have it pre-certified by then. Is there a solution for DECT NR+ deployments in China? I do not have the latest updates on the plans in the DECT NR+ updates in China, unfortunately. So that's also a good question that we can ask to our technical support guys in DevZone. And there's another question about some DECT NR+ stuff. I am not too updated on the certification requirements there, but the question is, are there any basic regulatory requirements for NR+? Does the stack need certification as well? As far as I know, there's much less certification requirements compared to cellular. So, but I do not have all the details here. So this is also a question I highly recommend you to ask to the technical support forum. And will SoftSIM only be supported by NRF 9161 and 31 and not the 9160? So that is our target on the SoftSIM. Viewed the commercialized SoftSIM solution is for the 9161 and 31. But we have customers that are evaluating the SoftSIM solution on the 9160, so that is possible, but the fully implementation is targeted for the new devices. Flash, so yes, it's truly dedicated for the application. Next question here: will Nordic keep the 9160, or will it be replaced by the 9161 in the future? So this goes for all of our devices. As long as customers keep buying them, we will keep them. So they will live alongside each other for the foreseeable future. If you do not need any new types of features, but want to have a product that's been stable for a long time and is still going to be maintained in the future, then the 9160 is a very good choice. If you want to have new features on the cellular side or are looking into maybe a DECT NR+, then the 9161 could be a better option. Next question: tiny machine learning / edge impulse integrations. Yes, we do definitely support that on our 9161 and 31, since we have already support for that in 9160. So for example, Edge Impulse is a partner of ours, and we have a very good integration in our NRF Connect SDK, so you can already use that now. And the next question: in your slides, NRF Cloud location services, what is the line about with the year numbers? Example 1 to 6 years. So that was basically a kind of a rough reference of the battery lifetime you could expect by using that type of location services, just to give you a kind of a comparison between a GPS versus a multicell or a Wi-Fi. So that's it's difficult to do a good estimate without actually knowing how often you do your tracking and sending that to the cloud, but this is just to give the difference here. Next question, when will release 17 of 3GPP be supported for 5G NTN? So the target on the current devices are not for NTN. This is maybe something we will do in the future. If you want to know more about our future plans, then you reach out to our regional sales managers and they can answer you there. And next question here, can you run DECT NR Plus and Cellular at the same time, or is it either or? Yes, the latter is correct. It's either or. So you have one modem on the 9161 and 31, and they can either run the Cellular stack or the DECT NR Plus stack. So you could have maybe an external flash that has the DECT NR Plus stack running, and on the modem you have the Cellular stack. And when you need to switch, you could do update the modem with the DECT stack and then run your DECT program if you need that. But in a use case where you have several thousands of DECT NR Plus nodes and you have different gateways, I would rather recommend to have two devices for the gateway, one running solely Cellular and one running solely DECT, to have a continuous possibility of streamlining the data to the cloud. But if you don't mind the extra power consumption or latency, then you can run one device as the gateway that's switching out the DECT NR Plus stack and the Cellular stack, basically. And next question, will there be a DK or a thingy with 9161? Yes, there will be a new development kit for the 9161 and also a new thingy, which we will call Thingy 91X. That's also on our slide deck, which will be available after this webinar. You can look it up there, but we will definitely have updated kits for the new device there. Next question. Will the new 9161 based Thingy 91 have external interfaces, e.g. UART? I cannot answer this right now. I think this will be answered in the future. I think if you don't want to wait, then reach out to your regional sales manager about details on the Thingy 91. I don't want to expose too much about the product that has not been publicly released yet. So that was all the questions on this webinar. Thank you very much for sticking around. And if you have more questions, please go to DevZone. If you want to watch one of our newest and latest webinars that's coming out, please subscribe to our webinar site. If you have any more information, if you want to know more about Cellular, then you go to nordicsemi.com/cellular. So thank you very much for sticking around and have a nice day.